All right, we're down into Royden's Auto Service, and kind of the next project that we're going to do is going to make some motor plates. All right, let's see what we got going on here. So it's just a small kind of two-bay shop. He's doing some nice brakes on some wheelwood brakes on an old Nova, and then our project back here is a little Brad Anderson motor going in a Camaro. So you can see what we've done. This is kind of the second iteration of little paper template. Made a couple of slight adjustments here on the hole locations, and we're going to cut this out of a 1/2 inch thick piece of aluminum and make some motor plates. Okay, so we're going to have much more in depth about this car and kind of the original OG Crazy Rat that this guy replaced. So we'll talk more in a future video about those two cars and kind of the drag scene here in Hilo, Hawaii.
Royden's Crazy Rat Wong.
All right, we're back here in the office, and we've got our little paper templates that we made some marks on, some minor adjustments, and we're going to show you how I got to this point with these paper templates, and and then beyond that, how we get our final, and then go out in the shop and cut them. All right, so you can see here. Here's the model, front of the block. This is just standard Hemi stuff. The Brad block is standard Hemi stuff. I'm not sure about any of the others, but the Brad block is standard Hemi. So we drew the front of the block, and then if I open up these guys, here's the motor plates, and then if we go over and we look at the sketch and edit it, well, I started with a piece of material big enough to fit, and then what we did is right there. I took his existing. He had a set of Bohr racing plates. I believe they're a company out of Michigan, and they did not fit the McCamus chassis. So what I did was I assembled the piece onto the Bohr that they kind of scabbed together, just so they could hang this thing in the car, give me something to work with. And what I did was took a picture of it, scaled it, oriented it properly so that it would fit the three holes on the block, and then sketched around everything. So this was solely driven by a picture sketch, basically. So yeah, that's how we did all that. And when you exit sketch, you end up with that part right there. And now what we have to do is make a few changes. Just polish it up a little bit, and we should be good to go. And I'll show you kind of how I do the next step. Okay, so here we can see the sketch. So what I did was I just scanned this guy. I just scanned him. Took him over to the scanner and scanned him. Just so happens it fits well on 11 by 17, which is kind of the max size-ish for our scanner. Scanned it, converted it to a JPEG because it came in as a PDF, imported the JPEG, scaled it, and here you can see what's going on. So the scan lays on the top surface, the picture, the JPEG lays on the top surface. It is right there. You can see it from both sides. right? So all we do is drop this down, get him to fit well line to line, kind of like that. Kind of like that right there. And then what we'll do is come over to this side, make a sketch, and we'll move those holes ever so slightly, and then suppress the other holes. Maybe trim off this edge like I've got right here. Trim that edge off, and away we go. All right, we got the design work done and brought it into Mastercam, and I've assigned some stock to this this side of it at least. And see, what we'll do is we'll make all our tool paths on this piece. We'll cut this piece out, and then we'll reassign the stock over to this piece, move it up to its origin where it needs to be. And then all my tool paths, I just have to pick the geometry over on this guy, and everything should be the same. Anyway, that's the theory. There we go. We got a big chunk of Kaiser, 1/2 inch thick. So I've got everything, right? Lot number, everything. So not incredibly important for this piece, but big piece right there. Knock the piece out, and the cool thing is I should be able to toe clamp this down from side to side, have it sit up on 1, 2, 3 blocks, and then just move these clamps around and chop out the outer shape, and then grab the edges, and while never releasing it totally, then just grab the edges and then scoop out the little bits for light weighting. So that is the plan. So here's the first setup. All I did was just visually align this edge with this surface right here on the table, and mark the center, and picked up the center, turned that XY0, touched off a tool, just barely skimmed the top, and that was Z0. And then what we're going to do is come in and we're going to cut basically the end of this out. We'll move these clamps to the end, and then we'll do these guys in kind of the opposite, right? We'll do these guys in, we'll cut this end, and then we'll reclamp back here on the cut portions, and then we'll cut the sides out. And then, because we'll be grabbing just the very edge, we'll be able to do everything in the middle in the next setup after that. Okay, here's the first setup on Mastercam, and basically I'm taking short, little shallow depth of cut, 80 thou, because this is hanging off and it's totally unsupported. 80 thou, I don't know how many passes it takes to get through that, but then one last 15 thou cleanup, and then like I said, we'll grab the end of this, and then we'll release these guys on this end, we'll move them in, we'll cut all this out, and then we'll grab this, and then we'll cut the centers out. Alright, I don't know if I've ever shown this before, but I've never crashed a machine. I've always used Mastercam. I kind of attribute it to that. So what does it for me is to verify. And here you can see the stock I've set up, and I can just run the program basically. And I'm sure Fusion does the same thing, but you know what? I've never crashed a machine. So there you go. So now we just post and send it to the machine, and we're making chips. There it is. First off is done. Now we're just going to move the clamps to something over in this neighborhood, and then move these guys over here. And then we can cut that in. Alright, so everything's done. Part is cut out. I've got 2 holes for the chassis bored in, and everything's a little bit of bench work on the back side of this guy. I'm gonna hit this on a sander and just break this edge. It'll look really nice when it's done, but I did do a 20 thou little 45 all the way around this part. Now what we have to do is where the bolts are that hold this down to the motor, we have to surface a flat area down to, this is 1/2 inch material, we got to go down to 1/4 inch. Because everything was designed for a 1/4 inch motor plate, I'm just adding some rigidity to this part and lightweighting it according to the design. So anyways, we got a pocket, and we're going to finish the edge in the same 20 thou little 45. So that's next. Then we'll punch the holes in, and we'll move these guys out to just grab this edge, and then we can do all the rest of this in one shot. And here's the cam. It's just a simple pocket, like 3 step downs, you know, because this is unsupported out here. And then a bunch of cleanups, both on the wall and on the floor. And then of course we come in with a little spot drill and fix up the edge all the way around. All right, here's the cam for all the pockets that are cut in there, and yeah, it's just a high-speed dynamic OptiRough. Get most of the material out, and then we follow up with a waterline cut to do the walls, the edges, and then I do a pocket, and that gets us this super pretty. You know, kind of textured pattern that matches a lot of the stuff that the automotive aftermarket's doing now. All right, so everything's done on this guy for the front side. The back side, all I have to do is put 189 thou notch in the back where the tab on the chassis has to seat in, so we get the proper depth. So basically all I'm going to do is indicate in this surface, this flat surface, and then set the thing up, you know, indicate that in, and then just make the cut on the Bridgeport. It's easy enough to do it that way. Then a little bit of hand work, cleaning this up, brushing the finish out here, and this guy's ready to go. All edges relieved, got the holes punched in there, and yeah, this guy's ready to ship. There we go. Nearly finished. The one thing I have left to do, like I said, backside, just notch this out. Basically, it's going to look like that right there. 190 thou deep little pocket. That's what we got. All the edges are broke. 20 thou on the outside, and on the inside pockets we got 30 thou chamfer. All right, the brackets are mounted on the engine. Motor plates on the Brad Hemi. And all of our holes look like they line up pretty darn good. This is for a breather for the ProCharger. These mounts right here, this is for throttle cable. And then over here on this side, this is obviously fuel regulator. And that guy bolts on to those holes up there. All right, so that's the workflow. That's how I do it, anyways. We start with we start with the bore plates that came on the motor, and then the guys kind of scabbed on some little brackets to give me an idea. I took the picture, I converted the picture into a JPEG, put it in SolidWorks, scaled it, aligned it, did the drawing, and then we did paper, printed 1-to-1. Took 2 visits to actually get the holes to line up like they do, but everything's good now, and that's the workflow. So anyways, stay tuned, subscribe and like and share the video, and more to come.